Hi, my name is Avi, and I'll be talking about recursion. Recursion is when you define a function by referring back to the smaller inputs of itself, often repeatedly, until it reaches a base case. Now, let's look at a problem. How many sequences of zeros and ones of length 19 are there that begin with a 0, end with a 0, contain no 2 consecutive zeros, and contain no 3 consecutive ones? So the first thing we can do is define a function, f of n. And we can set that to be the number of valid sequences of length n. Okay, so we know our valid sequence must begin and end with a 0, as stated in the question. So it begins with a 0 and ends with a 0. Now, we know we can't have 2 consecutive zeros, so the second to last digit must end in a 1, 0. Now we have 2 cases, so we can write case 1 right here and case 2 right here. So case 1 the cases will regard the third to last digit. So case 1 will make the third to last digit 0, and case 2 will make the third to last digit 1. Okay, so what we can do is we can try to split up the sequence. So if we take the first case and we split it right over here, we can make this into a sequence of length n minus 2, and this is 2. Now again, the total is still n. By splitting it up into a sequence of n minus 2, we've essentially made a mini sequence. So it'll be a valid sequence of length n minus 2, and then at the end there will be a 1 and a 0. So now what we're going to do is we're going to do something similar for the second case. Now again, since a valid sequence has to end in a 0, we have to extend this until it reaches a 0. So this next one, we have to decide the fourth to last digit. We know it cannot be a 1, as we cannot have 3 consecutive ones as stated by the problem, so this has to be a 0. And now we can apply the same thing. We'll split it. This is a sequence of length n minus 3. This is 3. So this is basically having a valid sequence of length n minus 3, and then add a 1, 1, 0 at the end. So this is the same thing as f of n minus 2, and this is the same thing as f of n minus 3. And remember that the 2 cases combine to make up f of n. We've just established what the first 2 or 3 digits is respectively. So that means we can write f of n equal to f of n minus 2 plus f of n minus 3. Now we want to find what f of 19 is. So to do that, why don't we just list out a few of the first cases, and then we can use recursion. So let's start with f of 3. So f of 3. So there are 3 digits. The first and last ones are 0. And we know the middle digit has to be a 1, because you cannot have 2 consecutive zeros. So the number of ways to do f of 3 is 1. Next, f of 4. f of 4, there are 4 digits. The first and last ones are 0. Now, this digit has to be 1, because you can have 2 consecutive zeros, and the same logic applies for the next one. So this, again, will be 1. Now f of 5. f of 5, we have 1, 2, 3, 4, 5. Again, ending with a 0 and starting with a 0. Again, for the same logic, this has to be 1, this has to be 1. And we know we can't have 3 consecutive ones, so this has to be a 0. And this is 1. Now we can start applying this logic. Now, f of 6 is equal to f of 6 minus 2, which is 4, plus f of 6 minus 3, which is 3. And this is equal to 1 plus 1, which is 2. And now we just continue doing the rest. So f of 7 will be f of 5 plus f of 4, which is equal to 2. And then we can just continue doing that. So f of 8 will be 3, f of 9 will be 4, f of 10 will be 5, f of 11 is 7, f of 12 is 9, f of 13 is 12, f of 14 is 16, f of 15 is 21, f of 16 is 28, f of 17 is 37, f of 18 is 49, and finally f of 19 is equal to f of 17 plus f of 16, which is 28 plus 37, which will give you the final answer of 65.